Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila Sofia binti Umar Rusli with metric number 301255. Today I would like to talk about three type of devices. Okay, we have three type of devices, which is dedicated devices, shared devices, and virtual devices. So for the first one, dedicated devices, it assigned to one job at a time. So for the entire time that job is active or until release. For example, tape drive, printers, and plotters. The disadvantages is it must be located for duration of job execution, and it inefficient if device is not used 100% of the time. Next is share devices. It assigned to several processors. For example, direct access storage device (DASD). Processors share the SSD simultaneously and request interleave. It act like device manager supervision, and it will control interleaving, predetermine policies, determine conflict resolution. Next is virtual devices. It's dedicated and shared device combination and device transformed into shared device. For example, printer, it's converted by spooling program. Spooling program is speeds up slow dedicated I/O device. Next, universal serial bus USB controller. The interface between operating system, device driver, and application and device attached via USB host. It assigns bandwidth to each device and priority base, which is high, medium, or low priority. Next, we will continue device management. It involves four basic functions. For the first function is it monitoring the status of each device, such as storage hardware, monitor, USB tools, and other peripheral devices. It enforcing preset policies to determine which process will get a device and for how long. Next, it allocating each device appropriately, and for the fourth function is it's deallocating each device at two level, which is at the process level when an I/O command has been executed and has temporarily released its device, and also at the job level when the job is finished and the device is permanently released. Next, we will continue I/O request management. I/O request is made by process. It involves transfer from memory to device or vice versa. OS via device manager handle this transfer via three modules, which is I/O traffic controller, I/O device scheduler, and I/O device handler. For the first one is I/O traffic controller. It watch status of devices, control unit, and channel. The three main tasks it determine if path is available. If is more than one path available, it will determine which one to select. And if all paths are VC, it will determine when one is available. It also maintains database containing each unit status and connection for each unit in the I/O subsystem group into channel control block, console unit block, control block, and device control block. In the figure 7.1, it show control block contain the information it needs to manage the channel. So for example, channel control block, it contain information such as channel ID, channel status, list control unit connected, and list process waiting. Same for the others, which is control unit control block and device control block. It's contain the information stated at the slide. Next is I/O scheduler. It is same job as process scheduler. It allocate devices, control unit, and channel. If request is greater than available path, it will decide which request to survive first based on different criteria. In many systems, I/O request is not preempted, and for some systems, it's allow preemption with I/O request subdivided and allow preferential treatment for high priority requests. Next is I/O device handler. It perform actual data transfer and it process device interrupt, handle error condition, and provide detailed scheduling algorithm. It is also device dependent, and each I/O device type has its own device handler algorithm. Next, Next, we will continue I/O devices in the cloud. When a user sends a command from a laptop to access a high-speed hard drive that's many miles away, the laptop operating system still performs many of the steps outlined in this chapter and expect an appropriate response from the operating system for the hard drive. Therefore, the concept explored in this chapter continue to apply even as the cloud allows access to many more devices. Local operating system role is accessing remote I/O device. It essentially the same role performed accessing local devices. And cloud provide more access to many more devices. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farika Maisara binti Muin. Today I'm going with metric number 3011 and 99. So today I'm going to explain about sequential access storage media. So we have various type of storage media. As for the first one, we have magnetic tape. So magnetic tape is basically the basic one that we all know. It's like a tape that we recorded by doing a circle. So it is an early computer system, routine secondary storage. It records stored serially, record length determined by application program, record identity identified by position on tape. Record access, the tape rotate passing under read or write head, only when access requested for read or write. For the time-consuming process, for the sequential access storage media, next one we have the figure diagram for the magnetic tape here. So the tape density characters recorded per inch depends upon storage method in individual or block record. Next, inter-record gap IRG, half-inch gap inserted between each record. Same size regardless of size of record it separates. Blocking, group record into block, transfer rate, tape density multiplied by transport speed. For the interblock gap, IBG, we have half-inch gap inserted between each block. More efficient than individual records and IRG. So optimal block size, entire block fits in buffer. So the advantage is its fewer I/O operations are needed, and then less storage space that will be wasted. So for the disadvantage is it will overhead and software routines are needed for blocking, deblocking, and record keeping. And it also buffer space may be wasted. Next, access time can vary widely. Poor for routine secondary storage accept files with very high sequential activity. Next, the DES disk include all devices that can directly read or write to an arbitrary place in storage. Directly read or write to specific disk area, random access storage device. And it has three categories: magnetic disk, optical disk, and also solid state flash memory. For the access time variance, it is not as wide as magnetic tape, and it record location directly affect access time. And for the magnetic disk storage, computer hard drive, single platter or stack of magnetic platters, as for the diagram below. And then it has two recording surface, top and bottom. Each surface formatted concentric tracks numbered from track 0 on outside to highest track number in center. Read or write heads move in unison. Virtual cylinder. Accessing a record, system needs three things, which is cylinder, surface, and sector number. So for the access time, file access time factors, seek time slowest, search time, and also transfer time, which is fastest. For the fixed head magnetic drive, we have record access requires two items, which is track number and also record number. So for calculating the access time, we have to add search time plus transfer time. DASDs rotate continuously for the three basic positions for requested record in relation to read or write head position. DASD has little access variance, which is good candidates, low activity files, random access, and blocking minimizes access time. So this is for the diagram for fixed head magnetic drive. For the movable head magnetic drive, the access time equal by seek time plus search time plus transfer time. So for the search time and transfer time calculation, same as fixed head DASD. Blocking, good way to minimize access time. So for the disk storage structure, this is the diagram to be more understand. And also this one. So for the HD performance, we have to add seek time to transfer time plus search time. This is for the calculation, and this is the example to transfer a 4 kilobyte block on 7200 RPM, this with a 5 millisecond average seek time, 1 gigabyte per second transfer rate with a 1 millisecond controller overhead. So for the calculation, we have to add all of these 5 millisecond plus 4.17 millisecond plus 0.1 millisecond plus transfer time. So transfer time equal by 0.031 millisecond. Thank you.
Assalamualaikum and good evening everyone. My name is Wardah with metric number 301178. On my part, I will continue for the subtopic of the device handler SKIK strategies. So, what is device handler SKIK strategies actually means? It is an algorithm used by disk drive to optimize the movement of the read-write heads over the platters to access the data. It is a predetermined device handler, which means it determines the device processing order. Its goal is to reduce the seek time, which is the time taken for this read-write head to move to the track where the desired data is located. Some common SKIK strategies are FCFS, SFTS, and scan. It is including the look and step scan, C-scan, and C-look. Every scheduling algorithm should be able to minimize the arm movement and minimize the mean average response time, also to minimize the variance in response time. First one is FCFS. With FCFS, the requests are processed in the order of the arrival. For the advantage, it is simple to implement and it's fair to all requests. And for the disadvantage, it requires an extreme arm movement and can lead to long waiting time if the requests are spread across the disk. But the FCFS algorithm doesn't meet any of the three goals of SKIK strategies that we discussed previously. Next is SSTF. With SSTF, the request with the track closest to the one being served, that is the one that has the shortest distance to travel, is the next to be satisfied, thus tending to reduce the seek time. It means it selects the request that requires the least movement of the read-write heads from its current position. For the advantage, it reduces the average seek time compared to FCFS. For the disadvantage, it can lead to starvation of requests that are far from the current head position. Next is scan. Scan is where the disks are moved in one direction. For example, it moves inward to fulfill all requests until it reaches the end, then reverse direction and services requests on the way back. For the advantage, it reduces the problem of starvation present in SSTF. It also balances the efficiency and the fairness. For the disadvantage, it increases the complexity with more subqueues. N-step scan is the division of the queues into subqueues up to n requests. Services each subqueue is using the scan. N-step scan is another version of scan. It holds all new requests until the arm starts on its way back. Any requests that arrive while the arm is in motion are grouped for the arm's next sweep. Next, look and see loop. Loop is similar to scan, but the disk arm only goes as far as the last request in each direction, then reverse. See loop is similar to see scan, but the arm jumps back to the start after the last request. For the advantage, it is more efficient than scan and see scan because it avoids unnecessary movement beyond the furthest request. For the disadvantage, it increases the complexity to implement this algorithm. The last, as the best strategy to implement all these algorithm is FCFS we use best with flight loads as service time unacceptably long under high loads. SSTF best with moderate loads as the localization problem under heavy loads. Scan best with light to moderate loads as it eliminates indefinite postponement, throughput and mean service time SSTF similarities. And the last, C-scan best with moderate to heavy load as the service time variance is very small. Thank you.
My name is Wanashaza Azrisha binti Mazin with metric number 301140. Now I will continue present Blu-ray disc technology. Blu-ray discs have the same size as DVD and CD. It have a smaller pitch and more tightly wound tracks. It also uses a blue-violet laser for higher data capacity and multiple layers. Blu-ray discs have three formats, which is BD-ROM, BDR, and BDRE. BD-ROM stands for read-only, BDR recordable, and BDRE is rewritable. And then solid state storage. Solid state storage stores data electronically with no moving parts. It made from silicon microchips. The example of solid state storage is SSD. SSD store data permanently using flash memory. Data operation like write, transfer, and erase are electronic and silent. The technology used in solid-state storage is Fowler-Nordim tunneling. It stores electrons in a floating gate transistor and data remains even after power is off. And then flash memory storage. Flash memory storage is electrically erasable, programmable, and read-only memory. The acronym for this is EEPROM. The features is non-volatile and removable. It also emulates random access. Flash memory retains data even when removed. It performs two functions, which is write data and erase data. When it write data, the electric charge through a floating gate. And while it erase data, strong electrical field or flash applied. And then this is the example for solid state storage. Solid state drive SSD is an example for solid state storage. The advantage of SSD is SSD have a fast performance, compact size, and no moving part, which is making them silent and lightweight, and also require less power. SSD also have disadvantages, which is it is very expensive, sudden crashes with no warning, and data transfer rates may degrade over time. We also have hybrid drives, which combine SSD and hard drive technology for a balance of speed and capacity. And then we go to the components of the I/O subsystem. The first component is I/O channels, which is programmable units between CPU and control unit. It synchronizes CPU and I/O device speeds, manage concurrent CPU and I/O processing, and allow overlapping CPU and I/O operations. The second component is I/O channel program. It specifies device actions and controls data transmission between main memory and control units. The third component is I/O control unit, which receive and interpret signals. The fourth one is disk controller, which connect disk drive to system bus. The last component is I/O subsystem configuration. The design of this I/O, it have a multiple path for increased flexibility and reliability. If one control unit fails, another can still access the device. And then we go to the problem solving strategies. The first one is track component status, which is it use structured interactions to know which components are busy or free. The second one is it handle heavy I/O traffic, which it use buffers and queues. The third one is manage speed disparity, which is also use buffers and queues. And then what it means with independence. Independence means when I/O units work on tasks alone. And concurrent processing means when CPU handles data while I/O occurs. Okay, device status have four status, which is flags, CSW, flag changes, and testing. Flags happen when CPU checks hardware flags. CSW happen when CPU shows component status. Flag changes from free to busy, and testing via polling or interrupts. It states that interrupts are more faster. And then we go to the direct memory access, which we often call it DMA. The function of the DMA is allow devices to access memory directly, especially for fast devices like disk. And then buffer. Buffer is a temporary storage in memory, channels, and control units. It improves data movement synchronization between slow I/O device and fast CPU. We also have double buffering, which means CPU process data from one buffer while another buffer is being filled. It enhances efficiency by allowing continuous data processing and transfer. Example of the double buffering is Step 1, CPU reads from buffer 1 while buffer 2 fills. Step 2, CPU reads from buffer 2 while buffer 1 refills. It means that CPU processes data from one buffer while another buffer is being filled. So we go to the RAID. RAID is a redundant array of independent disks. Overview of RAID is multiple disks as one, which means we combine several physical disks into a single logical unit. Mean that RAID is a multiple disk as one. It combines several physical disks into a single logical unit. The benefit of RAID is better performance and data recovery with redundancy for protection against hardware failure. The considerations is cost, speed, and application needs influence RAID level choice. RAID increase hardware costs. So that's all from me. Thank you.